Good morning, calculus. We're going to do section 4.2 today. I'm sorry, pre-calculus. That's all calculus, I guess. Trigonometric functions, trig functions, and trig functions are kind of what separate the algebras from the stuff above. If you know trig functions, it's kind of the next level up there. And hopefully you've done a little bit of this before you've come in here. So let's go ahead and get started. The thing that we remember is SOHCAHTOA. SOHCAHTOA. Okay, so sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Let's actually flesh this out a little bit. Okay, we have a right triangle, and here's your angle. And for angles, we usually use the variable theta. There's nothing terribly special about it. It's just that's what we usually use for angles. So the side opposite the right angle is hypotenuse. The side right of the two legs, the side right next to it is what we call the adjacent side, and the side opposite is what we call the opposite side. And so I will abbreviate like that. So sine of theta is opposite over hypotenuse, and I'm abbreviating here. Cosine is adjacent over hypotenuse. Cosine of theta, right, is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Tangent of the angle theta is opposite over adjacent. So those are the three major trig functions. We also have three more. and I'm going to kind of line them up: cosecant and secant, and cosecant of theta is the inverse of sine. It's h over o. So that's why I kind of put it underneath sine. Underneath cosine, I'll put secant. Okay, and that's the reciprocal of that. If I said opposite before, I apologize. It is the reciprocal, not the opposite. Opposite means negative. Okay, and finally, cotangent. Cotangent of theta is the adjacent over the opposite. So these three trig functions here are kind of secondary. They're just reciprocals of functions that we already have. So we don't use these ones terribly often. We use the three at the top for the most part. Okay, and if you want to convert between the two, you just flip it over or do 1 over that value, find the reciprocal, and that gives you the other one. So your calculator only has sine, cosine, and tangent on it because you can, if you want to know one of these other ones, you can just use one of those three to get there. One other thing I want to put here are special triangles. Special triangles. Okay, we will have three special triangles. The first two you might have seen before. The last one is kind of silly, but pretty important when finding the trigonometric values of certain angles. Okay, so here's a special triangle. I'm going to start with the 45, 45, 90. Okay, and when I write this triangle out, I'm going to write it in radians so you can kind of see what's what here. We're going to start to use radians a lot. I'm going to bridge between them for a while. We'll see both at the same time. But eventually, we're just going to use radians. Okay? And 45 degrees, that's pi over 4. So instead of writing the 45 and the 45 in here, I'm going to write pi over 4. So you can see 45 is pi over 4. Okay? And the sides we'll use here are 1 and 1. This is an isosceles triangle. And if we use the Pythagorean theorem, we can find out that the other side is the square root of 2. And so we can use these facts to evaluate some functions, but for now, that is our special triangle. Another special triangle, 30, 60, 90. Okay, so that might look something like that. Okay, 60 is pi over 3. 60 is pi over 3. I don't know how well we can see that, pi over 3. And then 30 would be pi over 6. Now we can take a couple of steps to figure out some values here. But this is going to be 1, 2, and then the square root of 3. Okay, and coming up with that is not too difficult. You start with an equilateral triangle with sides length 2, and then cut it in half, and then use the Pythagorean theorem. But that method isn't terribly important at the moment. What's important is that this is your 30, 60, 90 triangle. And one last triangle. This is the silly one, but it's just necessary for some. Well, let me go ahead and just, I feel silly saying it, but 0, 90, 90. Probably like, what in the world is he talking about? A 0, 90, 90 triangle. Well, sorry. That's just, I have to do it. Okay, so really, I'm going to put, let's put pi over 2 here, because that's 90, and 0 here, and this is going to be 1, 1, 0. In general, you know, the 1 here is opposite the smaller angle, pi over 6, so 0 is opposite 0, 1 is opposite 1, and 1 is opposite. So the pi over 2 and 90 degrees, they're the same size, so they both get 1. Here, pi over 4, those are both the same, so opposite those, you get 1. Okay, and we will use this later, and hopefully it'll kind of make sense later on. It is nonsense for now, though. Okay, it looks quite nonsensical. So how do we use all of this stuff? Well, let me give you one example here. Let's say sine of pi over 4. I want to know what sine of pi over 4 is. Okay, well, let's look for pi over 4, pi over 4. There it is. And there it is as well. This is isosceles, so I could use either one. Okay, sine is, let's look up here. Sine is the opposite over the hypotenuse. So let me use this definition. Okay, and I will use this pi over 4 right here. Opposite the pi over 4 is 1. So the opposite over the hypotenuse of this right triangle is square root of 2. So the sine of pi over 4 is 1 over square root 2. Sometimes you'll see it written like this. Sometimes they rationalize the denominator. So this is, in some circumstances, a perfectly acceptable answer. But sometimes we still like to rationalize that denominator. So remember, you multiply. Okay, remember, we don't like radicals in the denominator sometimes. But if we multiply numerator and denominator by the square root of 2, that will give me the square root of 2 over 2 times 2 is 4. The square root of 4 is 2. So that's another way you could see that answer written. You know, you'll look up answers in the back of the book, and you'll have this, and you'll be like, it's not there. It's because it is that. And those are the things I want to share with you about section 4.2, trigonometric functions, trig functions. Yeah.